Hello, you're welcome to this lesson. In this lesson, we are going to discuss the concept of nuclear charge, effective nuclear charge, and screening or shielding effect. Whilst we are discussing periodic variation, what is the meaning of nuclear charge, what is effective nuclear charge, and what is screening or shielding effect. Is that okay? Now we can explain this once we are collectively basing our argument on the structure of the atom. Is that okay? So on the board here, I have a diagram which is not drawn to scale based on the structure of the atom. Is that okay? Now, you can see I have a center here. This center here represents the nucleus. Is that okay? In the nucleus, we have the neutrons and then the protons. Is that okay? Now you can see after the nucleus there's another circle here in blue color. This one here, there's another one in blue, and the last one in black. Is that okay? Now these two blue shells represent the inner or the core shells. They represent the inner or the core shells. And then the last one, which is not blue in color, represents the valence or the outermost shell. The valence or the outermost shell. Is that okay? Now, another thing you could observe here is that there is a red dot indicated on the shells. Is that okay? The red dot indicated on the blue shells are known as the inner shell electrons or the core electrons. So the electron that I have on this shell and then also on this shell represents, the electrons here and the ones here. All these ones are part of it. They all represent the core or the inner shell electrons. And then the electron that is found on the last shell, which is called the outermost shell, becomes the outermost shell electron. Or we can call it the valence shell electron. Is that okay? Now I have another diagram here. So if this is diagram A, and then this is diagram B. In diagram B, there is the nucleus, that is the protons and neutrons. We have the nucleus here, but we have only one shell and there's one electron located on it. Is that okay? Now, what is nuclear charge? What is nuclear charge? Nuclear charge is the electrostatic force of attraction that exists between the protons and the electrons. The force of attraction that exists between the protons and the electrons is what we call the nuclear charge. So it means that when we take the protons in this nucleus, there is a certain attraction that is existing between the protons and these electrons in this first shell, the electrons present in the second shell, and also the electrons present in the last shell. That attraction is what we call the nuclear charge. So the nuclear charge is a force of attraction exerted from the proton onto the electrons in an atom. Is that okay? That is the nuclear charge. The force of attraction that a proton exerts on the electrons, regardless of the shell that they are located on. That is the nuclear charge. Is that okay? Alright. So over here, we could see that the proton here will be attracting the electron here. That force of attraction that a proton exerts on this electron here is what we call the nuclear charge. The word effective nuclear charge comes into the picture once there are inner shell electrons. So when you take this diagram here in diagram A, we could see that we have the nucleus present, we have one shell, another shell, and then the last one, that is the valence or the outermost shell. I said the two here are represented as the inner or the core shells. Is that okay? So these are the inner or the core shells. And on the inner or the core shells, we have what we call the inner or the core shell electrons. These electrons bring about blockage and they reduce the attraction. They reduce the attraction that is coming from the proton onto the valence electron or the last electron in the last shell. So this inner shell, they bring about reduction in attraction that is coming from the proton onto the outermost or the valence shell. But regardless of the blockage and reduction in attraction that is caused by the inner shells, the outermost electron will still feel some attraction coming from the proton, and that is what we call the effective nuclear charge. That is the net force of attraction that the valence electron will feel after the inner shell electrons that are present, which will be blocking and reducing the attraction made on it by the proton. That is the effective nuclear charge. So basically, effective nuclear charge will be high on the valence electron if only the nuclear attraction is very, very high. Is that okay? But if the reduction in attraction is very great, it means that the valence electron will feel only small attraction coming from the protons in the nucleus. That is effective nuclear charge. So basically, nuclear charge is the electrostatic force of attraction exerted onto the electrons in the atom, and that is coming from the protons in the nucleus of that atom. And effective nuclear charge is the net force of attraction that the valence electron feel after there is a blockage and reduction in attraction caused by the inner or the core electrons onto the protons, so that the valence electron feels some small attraction by the proton. That is the effective nuclear charge. Now, the last terminology we need to understand here is what we call the screening or the shielding effect. What is the meaning of the screening or the shielding effect? The screening or the shielding effect is a blockage and reduction in attraction. It is a blockage and reduction in attraction caused by the inner shell electrons. It is a blockage and reduction in attraction caused by the inner shell electron. So these are the inner shell electrons. These are the inner shell electrons. They reduce the attraction that is coming from the proton onto the valence electron. That reduction in attraction, that blockage that is caused by the core shells or the inner shell electrons is what we call the screening or the shielding effect. There is a variation that exists between the effective nuclear charge or the nuclear charge in general and then the screening or the shielding effect. Mathematically, they vary inversely proportional to the other, meaning that screening effects will vary inversely to, let me write it here. So let's use a symbol to represent them. So effective nuclear charge, let's represent it with Z, FF, and then screening or shielding effect, let's represent it with a constant, S. Is that okay? The variation that exists between the effective nuclear charge and screening effect is giving us effective nuclear charge is inversely proportional to screening effect. Or we can say screening effect is inversely proportional to effective nuclear charge. It simply means that once we have more inner shells or more core electrons, there will be more blockage, or there will be an increase in blockage in the attraction made by the proton onto the valence electrons. Is that okay? So if we have more inner shells, there will be more inner shell electrons. And while there's more inner shell electrons, there's going to be an increase in blockage and reduction in attraction made from the protons onto the valence electron that is available. Is that okay? So when that happens, it means that the nuclear attraction will be reduced. So the net force of attraction onto the valence electron will be reduced. So anytime there is more inner shells, there will be more inner shell electrons, and this will bring a greater reduction in attraction and blockage, and therefore the nuclear attraction, the net nuclear attraction on the valence electron will be small. So we say that mathematically, effective nuclear charge increases only if there is a reduction in blockage. And we can also say that there is a reduction in blockage, or the screening effect will also increase if there is a reduction in the nuclear attraction. This is the concept of nuclear charge, effective nuclear charge, and screening effect. Conclusively, we said that nuclear charge is an electrostatic force of attraction that exists between the protons and the electrons in an atom. But when we take some atoms, we have limited number of shells. So first of all, I said we have what we call the inner shell, and then the last shell represents the core shell. Any shell that is away from the nucleus or around the nucleus, but it is not the last shell, is the inner shell or the core shell. And the last shell in that atom represents its outermost or the valence shell. The electrons located on this inner shell or the core shells, we call them core shell or inner shell electrons. And the electrons located on the valence or the outermost shell is called the outermost shell or the valence electron. So for some atoms, they have only one shell. So since they have only one shell and they have one electron, in this diagram B here, it means that over here there is no inner shell electron to bring about blockage and reduction in attraction. So this one electron is going to feel a high attraction from the protons. Is that okay? But in atoms where they are fortunate to have inner shells, the inner shells will come along with inner shell electrons. And these electrons can bring about a reduction in attraction made onto their valence electrons. Is that okay? Now, how do we apply this basic concept in the variation of properties of elements on the periodic table while there is changes in their atomic number? Now, let's discuss that one as well.